Unit 4 is the unit of energy. It's 16 to 24% of your exam. So this is a big portion of your exam. Just want everybody to be aware that this is roughly 8 to 12 questions on your multiple choice section. And so the first, kind of how it's broken up is, this is the famous unit of WEP, work, energy, and power. And then in the first video here, we're going to talk about systems. And we talked about systems in Newton's laws, but we're going to have to distinguish not only about what is a system, but what type of system is it. Okay, so let's get started. The first thing is that a system, right, is defined as an object or a collection of objects. And the way to think about the object is like a bowling ball, right? So if it's a single object rolling down a bowling lane, right? Or it can be a collection of objects, such as a car. In a car, you have a motor, right? You just have all these things acting together, interacting. So you have the motor, you have the wheels, you have the people inside the car, and then everyone's car just has like stuff, right? In my car, it's a lot of like sports equipment, but everybody's car has like some sort of stuff running around in it. Now, AP does distinguish, or wants you to remember this idea that for each problem, it's the person who's going to choose the system. Okay, so everyone could choose a different system to analyze the problem. Sometimes the system's actually, kind of given to you, but sometimes it's not. And so now what happens is the objects in the system are going to be treated, or the system is going to be treated as having no internal structure. And so what that really means is, like, if we're talking about a car rolling down, driving down a road, then we're going to treat it as a car rolling down, or as just like a ball rolling down a horizontal surface. Okay. Now what happens is interactions can occur between objects within the system or of different systems. All right. And so this different idea, right, is when we talk about those external unbalanced forces, right? And that's what we talk about. It has to come from the outside, and so the systems are going to interact in different areas. Now, what happens is that the interaction is going to occur in one of two ways, right? The first way is a force is exerted by objects outside the system or inside the system, and then the other way is that we're going to have a transfer of a quantity with objects outside the system. Okay. Now, when we talk about force, this was unit 2. And then when we talk about this transfer of a quantity, this is unit 4. And I wanted to actually write something right there. And so this is the transfers where we're going to focus here in unit 4. Okay. And that quantity that we're going to transfer is energy. And so now, let's look at some ways to identify some possible systems. Now, it looks like this question is going to ask you to solve for it, but you can see right here we got a question talking about what are some possible systems for this problem. And so you have a ball thrown straight up with an initial velocity of 25 meters per second. The ball comes back down and hits the ground after reaching its peak. How high will the ball travel in the air, and at what time does it reach that height? So you can really look at this four different ways, right? There's 4 possible systems. The first way is just really looking at the ball only. And when you look at the ball only, what you're doing is you're going to analyze the change in motion of the ball. Okay, and this is what we did way back in Unit 1. All right, this was kinematics, right? So when we just said, okay, it's a ball traveling, that's all we focus on. The second type system, or the second system, would be a ball in hand. Okay, and then when you look at that, you're really looking at the interaction between the two. So the interaction between the ball and the hand. You may be asked, like, how much force there was, what's the acceleration of the ball, and this was more along the lines of Unit 2. And then you would have the ball, hand, Earth system. Okay, and a lot of people forget that Earth is a potential part of the system. And again, this would be, you could be looking at the interactions between the three. Again, this will end up being along the lines of Newton's laws. So this would be more of a Unit 2 question as well. And then finally you got the fourth system, which is where we're going to kind of live, right, over these next bunch of weeks. Okay, and that's the ball and earth system. And so you would see how the earth affects the ball. Right, and so we're just looking at that interaction between those two. And so this is, again, more along the lines of our Unit 4. All right, so you can see there's 4 different types of systems that you could analyze here. And you would have to choose, based on the situation, how do you want to solve this, okay? For this question, it may be easier to choose one of the first or the fourth type of system. You can treat it as a Kinemax equation, or you can treat it as an energy question. And we'll get into more about conservation energy here in a little bit. So there's basically 3 types of systems that we use. So the first one is an open system, and it's defined as where matter and energy can enter or leave the system, right? So think about like an open door, right? Open door means anything can go in or out. Now you have a closed system, which matter can go in or out, but matter cannot go in or out, but energy can. So again, if you think about like a closed door, right? The door is closed, which will allow like the sun to come in, right, if it has a window on it. But sun and light can go in or out. Those are forms of energy. But like I physically can't go in or out, right? And the last one is what we call an isolated system. And in isolated systems, right, energy and matter cannot go in or out. And the way, this is our goal here in AP Physics 1, right? Is we're going to assume all of our systems are isolated. So if I just do like a quick little kind of visual chart over here, okay, and I really define, right, which way can matter go in or out, or can energy go in or out, and that defines the system. And so in an open system, both of them can move in and out. In a closed system, only energy can, and then in a isolated system, neither can, right? And so the check marks represent that they can go in and out. The X's mean they can't. All right, and so now let's look at just, suppose you pour some coffee. I don't like to drink coffee, but I drink tea. Describe how this coffee can be represented as an open or closed or isolated system. And so if I just have your standard traditional mug, right? This would be an open system because I would be allowed to add in matter, right? So matter in the form of like creamer, milk. I can add in sugar or sweetener, right? But also note that energy will flow out of the system, and even it'll flow out through the actual material too, okay? But I can also warm it up, which means I can actually reintroduce in energy, right? So if the coffee gets cold, if I want to warm it up, I just put it in the microwave. Okay, and so, but you can see that what really defines this open system is that I'm able to put like coffee or sugar and creamer and all that extra stuff into the coffee. All right, the next one would be like if I had, a travel cup, or not necessarily a travel cup, but like if I go to a Starbucks and they give me, my coffee in a cup, right, or my tea in a cup. And so what happens is I can't put in all my added. So they'll put all the stuff to mix in, but then when they put the lid, and when we talk about closed system, we're talking about that the lid is completely shut, and we don't have to worry about reopening the lid or closing the lid. And so that would be how we can't add in all of our extra stuff because it's already there. But because the lid is essentially like just this plastic piece, right? It's easy for energy, and the cup is paper. So it's easy for energy to flow in and out of the system. And now finally the last one is an isolated system. And so if you think about it, now people will get these nice insulated cups, and they'll get these ones with these nice tight-fitting lids. Okay, I know it's like, there we go. Okay, and so again, when we talk about these lids, right, we're making this assumption that we're not going to pull it. And so if we had an insulated cup like a Yeti or a thermos or something like that, so here's our coffee, right? Energy will try to escape, but it can't, right? And so same thing at the lid. As long as it's a good, nice, tight-fitting seal, and the hole is very small or if non-existent, right? If you close it. But again, I can't put in, right, my after I put all my coffee and creamer and sugar in, right, all that stuff is going to stay in there, and I'm not going to remove the lid. Um, and so that's how coffee cup can be represented as each one of the systems. And so um, now what happens is in reality there are no really truly isolated systems, and that's the wrong pen. It's the marker. This is the one. Okay. Really, in what exists in our life, there's only one really truly isolated system. So the reason why there's no really truly isolated system is because a system from energy, it's always going to want to transfer in or out. Okay, so you cannot completely isolate a system from that energy transfer. As much as you want to try, you can't. And so here in this next section, let's just identify some systems if they're going to be open, closed, or isolated. So the first one is going to talk about an empty row of car. Should be car, not care. Okay, moving along the tracks in the rain. Well, this is going to be an open system because sometimes rain will get in through the windows. Maybe there's a door left open, right? And so that means that matter will be able to come in and out, right? Because the rain will come in. But also, when you break, there's energy leaving, right, in the form of heat. All right. Now, a covered pan of water being heated to a boil on a stove. Again, we're going to assume that there's no. We're not going to remove the lid, so this would be a closed system, right? So we're heating it up. So there's our energy, right? And because we have a covered pan, right, that means a lid, so we can't put stuff in. Okay. The Earth is an open system. If you want to think about it, like rockets leave, so matter leaves. Meteorites hit our Earth consistently, and so that means they come into our system. The sun heats us, right? So that means that we have energy coming in and out. All right. So the universe is really the only truly isolated system. Okay, because it encompasses everything. That means nothing really goes in or out of the universe. A well-insulated thermos. Now, the way to think about it, this is a closed system. However, we really want this to be isolated, right? Remember, nothing can ever really be truly isolated, and so the reason why is because there will be a heat loss. All right, a human being, simple enough. A human being is an open system, right? We eat food, which means matter goes in or out. If you want to say we use the bathroom, so that means matter leaves. And then, we lose energy by exercising. So that means our energy, right? There's our energy aspect. But also, when we take in food, not only are we taking in mass, but we're also taking in energy here as well. Okay, and so that's how we define a system. And really, we talked about that before, but in this unit, we're going to focus on open, closed, and isolated. In fact, at AP Physics 1, we're going to always assume that our systems are isolated. If you take AP Physics C, we make the assumption that they're going to be closed, okay, only because we will introduce in friction and everything like that. And so in the next video, we'll start focusing on this energy, okay.